Output visibility profile calculates a constraints map for a proposed development. The process is that you define your area of proposed development, you add any existing or proposed mitigating features into the model, including existing buildings, woodland, and also any site barriers that you are planning around your proposed development. You also decide where your critical receptor locations are going to be, and LSS will then attempt to draw a line from each of the receptors in turn to a user-defined grid of points within the development area. And what it will store is the lowest altitude from all of the receptor locations below which none of the development will be visible. We're going to add a proposed development in this area of the model, and to do that I'm going to add a fence, which is a 1.4 meter high feature. So this is my proposed mitigating feature, and I'm just going to create a very simple rectangular shape. I now decide my critical receptor locations, and I'm going to use this row of houses on the edge of this housing estate. And what I need to do is define these receptors with a unique point feature code. And for that I'm going to create one called PEYE. I would normally make it non-terrain, because if I want to place these eye locations above ground as if viewing from an upstairs window in a residential property, then I might want to add on a fixed amount. If I make them terrain features, then they will create a triangle up to them, and therefore they will create a shadow back to any further receptors behind them. So it's always safer to make them non-terrain features. And if I put a normal eye height in of 1.6 meters, and you could put a texture on there if you want and make it visible in 3D view. I'm simply just going to create a cross as my symbol, and I'm going to exaggerate the size of this so we can see it for this exercise. I now add those features. You can do that either by selecting it from the pull down list or just typing PEYE. I'm going to add 3 meters onto the ground level, so I'm going to add on a single story height, and then zoom in and simply place receptors. To make this more accurate, you would add these buildings into the DTM by creating heighted surface features, so that, for instance, this building here is creating a shadow and this building here is creating a shadow, so this one wouldn't be visible. Okay, well, I've finished adding a few points. There's about a dozen or so points there, and really what we want to know is what would be the limits of this development when viewed from these receptors. We select Output, ZVI ZTV Visibility Profile, select my point features, PEYE, create a new 2 meter grid inside this area, maximum sight distance of 10,000 meters, and adjust for earth curvature and refraction. I now define a rectangular grid within this development. The analysis is complete. Save and load. And before I load this file, what we need to be aware of is how the analysis has been performed. These are the eye positions with their respective point numbers, and these are the resultant levels inside that grid, inside the development grid, and the number in the number field represents the eye position which is restraining the height of that development more than any other. And in fact they are almost all point number 13. There's a few 15s in there and a few 11s, etc. Now if we've identified that point number 13 is the really critical point, then all we need to do is go to that location and then mitigate its view and run the analysis again. And hopefully the height values, these are DTM height values, will be higher next time. What we're saying here is at this coordinate location, if the development is created below that level at that point, then it will not be visible from any of the receptors. Let's load that in, and we'll zoom in to that area, and as we move the cursor around you'll see the height in the lower right hand corner. If we now draw the terrain model from the existing DTM, just draw a line across the screen. So at the back of the development we can design up to this height, but at the front of the development we can only design to this height. The dome shape of the original DTM model is allowing us to build to a higher height at the back of the development than at the front. And to interpret it even further, what we can do is if we output level difference at observations and call this max height of development. The other survey is the original DTM model. Load the points in and zoom into the proposed area. As we move the cursor around the screen, what we're seeing in the lower right is the maximum height of development at these locations. So we can build here up to 5.8 meters before it will be visible from any of the receptor locations. And you might find it useful to turn on the height bands. And we can see here that the maximum height of development is much higher at the back than it is at the front, as you might expect.